This is free algebra lesson 2-10, solving one-step inequalities by multiplying or dividing. Let's take a look at some things. Let's say we have the following equation or problem. 6 divided by 3, that becomes 2. And 12 divided by 3, that becomes 4. 2 is less than 4, so let's put a little less than symbol in here. Let's say 6 divided by 2. 6 divided by 2 is 3, 12 divided by 2 is 6, so that's still less than, isn't it? 6 divided by 1 is 6, 12 divided by 1 is 12, so that's still less than. 6 divided by negative 1, if you remember your rules for multiplying and dividing into here, 6 divided by negative 1 is negative 6. 12 divided by negative 1 is negative 12. Now suddenly 6 is greater than negative 12, isn't it? 6 divided by negative 2 is negative 3. 12 divided by negative 2 is negative 6. This is still greater. And 6 divided by negative 3 is 2, and 12 divided by negative 3 is 2. Negative 2 and negative 4, and negative 2 is bigger than negative 4, so we have that. Okay. Let's take a look at what happens when we multiply. 6 times 3 is 18, 12 times 3 is 36. 36 is definitely bigger than 18. 6 times 2 is 12, 12 times 2 is 24, 24 is bigger than 12. 6 times 1 is 6, 12 times 1 is 12, 12 is bigger than 6. 6 times negative 1 is negative 6, 12 times negative 1 is negative 12. Negative 6 is bigger than negative 12. 6 times negative 2 is negative 12. 12 times negative 2 is negative 24. Negative 12 is bigger than negative 24. 6 times negative 3 is negative 18. 12 times negative 3 is negative 36. Negative 18 is bigger than negative 36. So if we look at this, what do you notice happens to the inequality sign when you divide by a negative number or multiply by a negative number? Okay. Here, the inequality sign stayed the same. It was this way, and all of a sudden it reversed and went this way. Same thing happened over here. We began, and our inequality sign was a less than, and all of a sudden down here, our inequality sign became greater than. Which means when you multiply or divide an inequality by a negative number, in order to keep that inequality correct, you have to reverse that inequality symbol. Okay? This is very important. That's why it's in a big red box. If you multiply or divide each side of an inequality by a positive number, you leave the inequality symbol unchanged. However, if you multiply or divide each side of an inequality by a negative number, you reverse the inequality symbol. That's not if you get a negative answer. That's if you multiply or divide by a negative number. That's very, very important. Only if you multiply or divide by a negative number, not if you get a negative answer. So be careful with that. All right, so let's take a look and see how we're going to apply that. Let's say we have these. We're going to solve these inequalities. 64 is less than or equal to negative 8k. To solve for k, I'm going to divide both sides by negative 8. Divide the left side, the right side, divide by the left side. Since I divided by a negative number, my inequality sign must switch now. Because I divided by a negative number. It doesn't matter if I get a negative answer or a positive answer. I divided by a negative answer, negative number, so my inequality sign switches. So I get negative 8 is greater than or equal to k, or the way I prefer it, k is less than or equal to negative 8. And we're not going to have to graph these. We don't want to graph now, so we're not going to graph these. Number 2, y divided by 4 is greater than 3. To get y by itself, I have to undo division by 4. We undo that by multiplying by 4. Multiply this side by 4, multiply this side by 4. These will cancel out. Y is, we keep the inequality the same because we did not divide by a negative number. We did not multiply by a negative number. We multiplied by a positive number, so y is greater than 12. Number 3, negative 5x is less than 0. So we're going to get x by itself. We're going to divide by a negative 5. Divide by a negative 5. We divided by a negative number, which means my inequality sign will switch. Okay, and 0 divided by anything is still 0, so x is greater than 0. My inequality sign switched. Okay, pay attention to that. And 0 can't be negative, so it stays just as 0. Let's look at number 4 here. 3x is less than negative 21. Let's divide by 3. Divide by 3, divide by 3. X is less than. We did not divide by a negative number. We might have a negative answer if we get 7. But we did not divide by a negative number, so we do not switch the inequality sign. Okay? Don't switch sign because you do multiply by a negative or divide by a negative. Okay? Sign stays the same as it was here because we divided by a positive number. Doesn't matter if you get a negative answer. If you get a negative answer all you want. The answer doesn't matter. It's whether or not you multiply or divide by a negative number. Number 5, negative 7b is greater than negative 21. Let's divide by negative 7. Okay, these will cancel out, giving us d. We divided by a negative number, so we will switch our inequality sign. Negative 21 divided by negative 7 is positive 3. And we have d is less than 3. Okay, so number 6 here. P divided by negative 5 is less than 9. Opposite of dividing by negative 5 is multiplying by negative 5. So we'll multiply both sides of the equation by negative 5. These two will cancel out. P, I multiplied by a negative number. So my inequality sign will switch. And 9 times negative 5 is negative 45. And that P is greater than negative 45. Number 7 here. 1/3 b is greater than or equal to negative 31. And then multiply b by 1/3, so we have to divide b by 1/3. Dividing by 1/3 is the same as multiplying by its reciprocal. Remember that with fractions. If you have a fraction, dividing a fraction is the same as multiplying by its reciprocal. So instead of dividing by 1/3, I'm going to multiply by 3 over 1. Because here, everything will cancel out. I get b is greater than or equal to, because we did not multiply by a negative number. Negative 31 times 3 is negative 93. Okay, so b is greater than or equal to 93. Here we go, number 8. Negative 8x is less than negative 64. We're going to divide by negative 8. We divided by a negative number. So x is, we're going to put the inequality sign, greater than 8. All right, let's take a look at writing some inequalities from a sentence. Okay, write an inequality for each sentence and then solve. A number k multiplied by 7 is less than or equal to 21. Okay, a number k, k, multiplied by 7 is less than or equal to 21. Okay? Kind of an ugly looking equation. I'm going to do this a little bit nicer. I'm going to make this 7k is less than or equal to 21. That would be more algebraic because you normally put the number before the variable multiplying. So I have 7k is less than or equal to 21. So I'm just going to solve this. Divide by 7. Divide by 7. So k is less than or equal to 3. So our answer here would be twofold. One answer is the inequality itself. The other answer is the solution to that inequality. So there is our answer. There's our inequality, and there is our answer to the inequality. The quotient of the number p divided by negative 5 is less than 9. Remember, quotient means divide. Okay? The quotient of a number p divided by negative 5, okay, which I would prefer you write as p over negative 5, is less than 9. There we go. We have written our inequality. P divided by negative 5 is less than 9. Okay. To solve this, we multiply both sides by negative 5. This cancels with this, leaving me with a positive p, but since I divided by a negative, I have to switch my inequality symbol, and I get negative 45. So my solution here, the inequality was p over negative 5 is less than 9, and the answer for that was p is greater than negative 45. So there's my equation and my solution. Okay. The only difference between solving inequalities and solving equations is you have to remember, if you multiply or divide an inequality by a negative number, you must reverse the inequality sign in order to keep the inequality back.